Good afternoon. In today's video, I will be continuing Dynamo course for beginner series that I started a couple of weeks ago. Specifically in today's lecture, I think it's the 10th lecture, I will be continuing Dynamo points topics that we started in it, or actually in the previous one, sorry. I was talking about how to make a point with a Cartesian system and how using this point, how we can use this point to create a linear array. Again, in this video, I will be using a metric file. Make sure that it's set to meter, not millimeters, and I will create a new Dynamo file. Again, guys, make sure the file you are working in is a project environment, not a conceptual mass, and also not a Revit family. This must be a project environment, and if you don't know what I mean, for those of you, just go ahead from new one project and go to English metric system. Now back to Dynamo. In the previous lectures, I was talking about how to create points. Anyway, that's quickly I'm gonna do it here, and then I created a range. And in the range, I just connect, let me make this bigger. I connected the sequence resulted out of this range to the X, and as you can see that is the default value being generated here down in Dynamo as a real geometrical point, but in Dynamo, sorry, in Revit, it's just a ghost, so it's not really yet been sent as an actual point. Anyway, we need a slider. I always forget the I for some reason. You can go ahead and set this slider how you like it, maybe maximum 50. Each movement in the slider will give you 0.5. Anyway, let's set it to 0 as a start point. I'll select it, and you can see that the bluish rectangle around it. Hit Control continuously on your keyboard, and then drag it to make a copy of it. And let's the end goes maybe let's say 20. End of the 20. Right click again. I will create a slider here, but this time I will have an integer, so it have a whole numbers for me representing its steps, and I will connect it straightforward to the step range. The step input port in the range node. Now it's basically created from 0 to 20, and it jump each one as you can see in this range. Maybe I will make it 10. It's gonna be easier and quicker for us to observe, and that's the point here. And as you can see that we are feeding only the values for X. I can just select all those guys and just drag with or previously continuously pressing on Control, and then drag that, and I will connect this series now to the Y. And the thing, because we are expecting to create a more like a 2D array or a rectangular array, but when you give this value, what actually happening is that Dynamo take the first number here and the first number in here and give you 0, 0, so that's the first one. And in the second try of it, it goes to the number 1 here and number 1 here, and create a point by 1 by 1, and that will generate for you this again another linear array, but this time goes in a 45 angle. And in order to create a 2D array out of that, you have to come to the point itself, right click on it, and from the lacing you go ahead, and because it's auto or shortest for the current condition, you go ahead and change that to the cross production. If you have a previous I think Dynamo 1, you will not see this one. I think even in Dynamo 2 you will not see this one, the auto one. You're gonna see only those 3. Anyway, you choose this one, the cross production, and in this case you're gonna find that each point you generated here in let's say again, let's open those. Each point you have in 0 here, it will go and bring the value here in another 0, and then 0, and then 1, sorry, here 0, 1, and then 0 with 2. So it's generally take every point in here and make every value in here and take a value here in front of it, making from those 2 values a point. And then when it's finished with the first 10, as you can see, if I select the sublist here, you're going to see all those. It's gonna go to create another sublist, as you can see, which is here, based on 1. So it's gonna take 1 with 0, then 1 with 1, 1 with 2, and so on and on. I will try later in this, after this lecture, in the next lecture specifically, to talk about lacing and to show you the difference between each one of them. But for now, in order to create a rectangular array or 2D array, this is what you need to do. And then simply you can change what you want. Maybe this, make it 5, and you're gonna have 5 rows with 10 columns and so on. You can change this one to make it 4 instead of 1. You can make 2, and that will generate for you a step of 2 instead of 1 between those values. In this case, you're not going to reach 5. Be careful of this, because you have 0 and then 2. It jumped from 0 to 2 and then from 2 to 4, and it cannot jump to 6 because it's going to be over the maximum value specified by the end here, which is 5. Anyway, so let's make this 2.5, and by this we're going to have that exactly ending at 5, and some reason it's crushed in here because this is an integer, so it doesn't accept 2.5. My bad. So I'm going to keep it as 1 and make this 5 by 10 linear or rectangular, 2D or rectangular array. Now to create a 3D array, I can just simply select all those and copy them down, or I just make it easy for myself and take the same value and give it to the Z. And as long as this is still on the cross product, you will notice that there's a 3D array or matrix of point, as you can see, made of 10 in the X, 5 in the Y, and 5 in the Z. And that's almost it if we want to create, or understand how Dynamo can create 2D arrays and 3D arrays, or how you change from this one to this one based on a very basic point by coordinate system. But if I just deactivate this one and try to create a useful example here from this one in Revit, so I'll go ahead and add I'll add family and instance here, and let's say it's by point. So I'll pick this one. So I'm going to use this array that I defined to place any elements that I want directly from Dynamo to Revit. So let's connect those points. This family instance, as you can see, it's going to create instance Revit instance, and it depends on the grid of points, so it needs the points, and I'm going to provide those points. We actually create them. And the next type we have family type, so I'm going to go family and then hit space, and I think it will be the first one. So I'm going to select this one here, and I'm going to select whatever available. Let's say desk, maybe this one. Yep. And when you connect this one to the family type, it's going to generate for you desk at each point. And you can see they are overlapping, which is a good idea or a good opportunity here to go and change the distances. So maybe we go and make this 2. And now we see that clearly better than the way we had before without the overlapping. So that's a very basic way to create something useful out of this. I know this tool is available in Revit as a rectangular array, but not in all option. If you want to see the whole option that's not available, go back to the previous lecture in order to see the missing, the full abilities to create a parametric array here in Dynamo, because some of the function I explained yesterday is actually not available in Revit right now. So can we push that a little bit further? Let's have a look. So I'm going to push this a little aside. I'm going to use family instance again, but this time I'm going to use SetRotate node, and I'm going to add this one. So this is here, and it need now a degree. So again, slider, that's what we need. Again, I forgot the R. That's just me. I will go to, I don't know, let's go integers. And let's change the maximum value to 360 for full rotation amount. And I'll put 5 as an incremental value, and I'm connecting this guy here. And now you can rotate all those objects, around themselves, and even go to the 360, each one of them will rotate in the same time. As I noticed, it's not 100% rotating around themselves, and that's something to be accustomed about. It get used to it, because it kind of depend on how the family itself has been generated. And this is the point, and as you've noticed, when you rotate, it isn't actually rotating around the point itself. What if I choose the different family? Let me go ahead here and choose, let's say, what do we have in here? Let's make any type of trees. It's more like to comply with this. Anyone see any tree here, guys? Yeah, here we go. So maybe this one. No, it's a mess. It's okay. And they are overlapping, so I'm gonna need to come here again and adjust the maximum number, maybe 50. And in this case, let's say the gap between each should be 5. That's better. And I'll go here 50 and then 5 in here. What I've done. Yep, better. So you see now, if I zoom a little to the families we have in here, and I go and rotate, those guys should rotate, according to their centers. As you can see now, they are much better responding, as that is the center point of this specific family or tree, and it's rotate correctly around that center point, which is the point that we actually created. So the point is that each family you place depend on how and who actually designed it and how it's been designed, and the result will be totally different. Maybe the coordination system or the way the family itself been generated is not 100% match or actually aligned to the corner, instead as a base point for the modification, instead of this one, which is have the same center point of it as the same center for the geometry as the center for the rotation. So be careful of this. Don't expect all the families to respond the same. This is the point that I was really I wanted to focus on. And also, when you go ahead and create 3D arrays with families, because I know you're gonna try lots of stuff in here, and I don't want that to be 5. It's gonna be too much for my machine, so I'm gonna zoom in here. Maybe I will go 10. So just 2 arrays in this case, and I create the Z value and make this as a 3D thing. I'm not gonna see here anything, so I need to go to 3D. Yep, as you can see, let's shade that. See, now what we have in here is a 3D cubical array of those trees, and its work, and it successfully can be created. Again, do not expect Dynamo and Revit to make the successful result all the time. And the reason is that this specific family is designed to float and change its height very easily, because it's actually a tree, and might be you place it in a different topology with a different height. It doesn't have a clear constraint to the level. Existing doesn't require to be constrained to a level. Have a look if we change now the family to the table itself. The table, in the other hand, is a furniture family, and it will need a level to be placed, and you might expect some errors, or not the 3D array will not work as you was expecting if you use these types of family. So let's have a look. And as you can see, it's only one, and it's only attached to the level. And the reason is that these guys are designed the way that they really need a specific level to be placed on. They are not free to be moved in the Z-axis, not like the same way that the tree has been designed by whoever designed the families for those two things. Though this is the point that I wanted really to emphasize on, that different families will react different to the array you have and the nodes you have here in Dynamo. So don't get frustrated. Just try to find a correct family that work the best with your design. That's the point. And the second thing, again, if you change this to Revit conceptual massing or Revit family, again, some of those nodes and some of the families will not be available, so you might not get the same result. So specifically talking about this example, I'm talking here about the project environment. And again, have a quick look at those two groups. Those to the left here, we have them. They are fully 100% designed to work with the pure geometry inside Dynamo, but those guys here specifically are actually, you know, dealing to export the information from Dynamo to the Revit project environment or any other environment that might be suitable with them. I wish that you find this video useful, guys. I will try in the next video to talk about you know, the lacing and how you deal with the different possibilities, so you understand the lacing 100% in the next video. Thank you very much for watching and have a good day. Bye bye.